The last thing to do before calibration is to check that all the air tightness in the system is that the system is tight itself. So for that we're gonna do the test now, and for that we will need to turn the system into stop mode, because of course if it's in the run mode then it's going to be blowing through all the tanks, and we don't want to see the tightness away from the system but inside the system. So we turn it into the stop mode, so the system is just waiting for us to do something. Then we're gonna need one of these things, which is a ball valve, and what it does is just close the airflow between the supply and our system. Then we need also a digital pressure indicator. We cannot use this one because we're gonna close it from here, so we need a new one. We need another one to test. As well, we're gonna need some soap with water, and the reason for that is it's easier to see the bubbles coming out if it's any leakage. So first of all we're gonna connect this one. So we close the air and we put our indicator in the middle so we can see what the pressure is. And we turn the air on again. And here we can see that the pressure is the 2.5 bars, which is the same that it's indicating here. So now we're gonna check first the tightness in this block, which is the 3-way valves block. To do that, we're gonna first be sure that the system is we have this switch here and is in off mode like this, and that means that we are not giving any air to the other blocks, but just the air is getting here. So all these are closed and are supposed to be closed. If there's any leakage now, it means that one of them it's failed. It's failure. So now we have 2.5 bars because we have the pressure on, but at the time we close it, so the air, as we can see here, the air is just in the block, and it has to be stable. It's not going down, and this is the way it should be. It's not going down. If there was any leakage in the system, then the pressure will just drop. To check that the system is, if you have any leakage or something, you can put back the pressure, so you have a lot of pressure in the block, and then test with the soap water in the cap of the valve, because they're supposed to be open sometimes there, so sometimes they can be leaking there. So you test in the cap. You can test in the bottom as well. So you see that just now there is no leakage at all. And in all the couplings, you have to check all the couplings. So when you're sure that this part is tight enough, so you can continue with the next blocks. So to do that, we need to provide air to all the blocks. To do that, we open these valves all at the same time with our switch. So now the air is not only in this block, but in all the blocks at the same time. So the air is in all our system. So if we now close this valve, the air is also supposed to stay. But now we're going to be sure that all the system is tight, not only the block down there. So we close the valve, and the pressure is dropping a little bit more than before, but it's still good. You can count to 10 seconds, and if you haven't lose 10 centimeters or 1 centimeter at least, then the system will be okay. This is 2 meters and 38 centimeters, and we haven't dropped nothing in the 10 seconds I've been talking now. So it's actually, this is good enough. To find the leakage, if you have one, then you do the same. You turn the pressure back on, and then you test in all the couplings as well. The most common couplings that may have a leakage are here in the pressure sensor coupling, all the couplings here, and the boundary couplings down here. You do the same with the brush, with the water with soap, and you check that no bubbles are coming out.